So this is just a wee introduction, just to give lay out the gist of what I was discussing and what I'm proposing with some of the people that you're going to see in this interview. So just to make it clear for everybody, regardless of what you believe in, if you really want this to be, this whole debate, as people like to classify it, although, objective reality is not an idea to be won or lost by debate. It's about what can we actually demonstrate, what can we measure, blah blah blah. So here, I can see a very simple way, and it could be, we can limit the cost of this, and I'll get to it in a minute. So what I was asking these chaps here was an example, just so that you know and you understand, that regardless of the topography of the ground underneath us, so if we started here with, a sloping, piece of earth, what the proposition is this: if, because here's the thing, on the globe, regardless of what anybody believes, even on a globe, plumb, it doesn't matter, because plumb is always relative to the centre of the earth, so that's always, the starting reference point. Okay, so if we start then with, an example like a piece of ground like this, and we have a plumb line, you just need to excuse that it's not perfectly straight for this purpose, but we assume here that we've got a perfect plumb, okay, and we construct a post here. Now what we would have is we would construct, this is the relative position, this is the relative starting point. So what we would have squared blocks. Obviously I'm not going to draw them squared, but squared, if you don't understand, look up the definition of squared. And what we do is we construct each block relative to the starting position and relative to each other as we build along, so that they're perfectly square, same dimensions, square blocks out like this. Now if we had a hill, what you would see is that there's an increase in the gap from there to there, as opposed from here to here. Now that would be detectable, that would be measurable. Okay, so the proposition then would be, well, let's identify a region. So if we can get people to agree upon the curvature rate of the supposed globular earth and how much it curves over, say, half a mile, what we can then achieve is that we could dig a trench on a beach. We can dig a trench, and then we can fill that trench with water, let the water settle. So there's people out there that believe that the standing body of water is actually curving, it has to curve with the earth. So if the water was actually curving downwards relative to the starting position, again we would place the plumb line. And if the body of water was actually curving as we build, again the same principle, because this here has got nothing to do with the topography or the earth underneath. This is only relative to the plumb line and being square, perpendicular to the plumb, and we construct it and we build it out, say over half a mile. What we're going to see again in the first example is a difference from here to the end point. What should happen is that we should get a gradual increase in the gap from the bottom of the construct to the surface of the water. Okay, this can be done. It's not going to cost a whole lot of money. What we need to get involved is we need people who are curious and interested about it, and as I say, we can put this to bed once and for all. The plumb line, straight up and down, it doesn't matter if you believe in a globe or whatever you believe in, that's the relevant starting position. And if we construct from that point, we should see a deviation of the topography of the earth underneath us. In this proposition, we're talking about the surface of the body of water. So for me, we all know we have plumb and we have level. Okay, and this here is perfect 90 degrees. So each block would be squared and it would be relative to the starting plumb line, which would be this part here. Okay, and as we construct that out, if the earth and the body of water was indeed curving, you would be able to detect, that would be measurable. So as I say, that is not going to cost a whole lot of money. We don't have to have endless debates and beliefs, misunderstandings. We can put it to bed once and for all. And I want to put it to bed once and for all. Let's establish what's actually going on. in regards to the shape of the earth, and we can make this happen. If you're serious about making it happen, get in touch. Anybody out there with, you know, access to materials, you know, anything that we can use tool wise to make this happen, I would love to hear from you. So, and again, you're going to hear what the people in the real world who construct think about this and what they would expect to see, and regardless of what you expect to see, reality will show us what is actually going on. What's your name, bud? What's your name, bud?
Peter McDonald.
Peter, how's it going, Peter? Peter, the test is, right, we've got a plumb line, right, you know, a plumb line, and we've got it next to a steady body of water. So we dig a trench a mile long, we fill it with water, let the water settle so it's nice and levelled. Got a plumb line at one end of it. For that plumb line we build one post, and each block we build is squared to the post. Will the water line underneath align with the bottom of the construct, or will the gap start to increase as we go along building it?
We started to increase.
We did start to increase.
No.
So the water level line,
It's level.
right?
Yeah.
If we build a post at the edge of it,
Right.
we put our first brick, so the first brick's square to the post, perpendicular with the water. So it's a square block, and we build square blocks, square to each block, all the way along the water. Will the gap at the bottom of the block between it and the water increase, or will it stay the same all the way along the body of water?
Stay the same.
Why was that? So that's how water behaves.
That's it.
Water finds its level.
That's it, finds its level.
So, do you think that's what would happen if we built it?
Aye.
You ready to go?
Aye.
Right, cheers, my man. Right, how you doing, guys? My name's Del. How you doing, Del? Right, the puzzle is we dig a trench a mile long, okay? We fill that trench with water and we wait till the water settles, right?
Right.
How would you describe the surface of that?
Not very good.
No, the surface of the water, how would you describe it? Once we dig the trench and we fill it with water a mile long, how would you describe the surface from one end to the other?
It's smooth, isn't it?
Level.
Level, aye.
Right, so at one end of that then, we build a plumb line,
Aye.
and then from that plumb line, right, we get a post, and we build one block which is squared perpendicular for the post and the water line. So we've got a perfect square block, and we build the blocks all the way across the top of the water surface. Would the bottom of the blocks line up with the bottom of with the level of the water, or would the gap increase from the bottom of the blocks to the water as we went along?
So go with the bottom of the water, would it?
The water would always align, it would always be the same gap from the bottom of the bricks all the way across, wouldn't it? Because water always finds its level.
That's right.
When you build things plumb and square, it's always going to show, you've always get true level. I'm trying to get this done. The reason why I'm trying to get it done is because people are trying to tell me that curved, level actually means curve. People believe that if I dig a trench a mile long and fill it with water, that the water's actually curving. Because they say, it can't be curving, can it?
No.
Do you think the world's a round ball?
That's a mystery, that one, isn't it?
But if I build this construct, right, and the world really was curved, that would show it, would it no?
Of course it would.
Of course it would. What do you, what's your prediction if we get it done?
I reckon it'll be level.
You reckon it'll be level? So you're going to consider then that the world's not a round ball the way they show you on the TV?
Maybe it's flat.
What's your experience of reality? What do you experience it as?
So what do you reckon yourself?
Just experience what's on the TV, a round ball, didn't you?
You're on a ball. What's your direct experience of reality?
We're just getting sand down.
Never mind the TV. What do you experience it as?
Flat.
Flat. No curvature anywhere. Bodies of water don't curve, they stay level. Surface is always level. That's your experience. But you would doubt that based on what you see on the TV.
On the TV, aye.
Would you doubt it then?
Well, it's what you see, isn't it?
So where does your mind go now that I've pointed this out to you?
On the air.
So do you think it's a worthwhile endeavour then, because the earth's never been measured to have curvature, and if we get this done, dig a trench half a mile long, build a platform across the top of the water, it would show us one way or another whether it was curving or no. You agree with that?
Probably.
Do you think it's a worthwhile endeavour?
It's worthwhile endeavour, right?
Excellent. I'll be putting it out there and hopefully people will volunteer to get involved in it.
Alright.
Pleasure speaking to you.
Good man.
Thanks, man. What, did you hear much of that?
No, I never heard much of it.
No. You interested? You want to try it?
The Sunday he done what he had to do.
No worries. Appreciate it, guys. Thanks for your time.
What does that go on?
It's just my YouTube channel. I go to the universities and I'm trying to challenge them, you know, challenge the physics. So I'm trying to get this done. because you know there's no scientific experiment that can prove that the Earth's round. But if we build this, then it'll prove once and for all that water lies flat all the time. Doesn't it curve? Thank you guys, appreciate it. Up for a wee puzzle while you wait? No? Oh, you go, you go. Are you waiting? I'm making a wee YouTube video. Do you do the building work?
No big,
No,
fuck
you know.
I've got to stop you, see. I see you for most of it.
No, that's just me, I've just parked there, you're alright.
You okay?
Ah, you better move like that guy in. No, I'm not waiting, mate.
Alright.
I'm going to ask you to help me out though.
Aye.
While you're waiting, wee bit of fun. It's a wee bit of fun, I'll ask you a couple of questions if you're up for it. It's easy, easy as fuck. Just to try to get people involved in it. You up for that? I'll ask you the questions, if I tell you it'll ruin it, is that alright? Right. Hi buddy, my name's Dale.
Alright,
How's you going?
Alright.
Right, the puzzle is, we've got a bit of grun, right? And from one end of the grun, we're going to say it's a mile long, right? So from one end of the grun to the other end, there's a drop of 8 inches, right? But at the first side, the highest point, we build something that's perfectly plumb, right? Now that's our reference point, and from that plumb, what we get is perfectly squared blocks attached to that plumb, and we construct the blocks all the way out, right, across that mile. Would that construct show us the deviation in the drop from the start of the plumb line to the edge of where we're going, the 8-inch drop?
Should do.
It would do, wouldn't it? Because plumb and level will show that. So take it another step further. If I dug a trench a mile long and it was watertight, and I filled the trench with water and I left it to settle so that the water was perfectly still, we would have a nice level equal plane on the surface of the water. Do you agree with that? A mile long trench with water in it, would the surface of the water be nice and level?
Surface would be, aye.
So same again, we start at one side of that trench and we put the plumb line, and we start and we build the square blocks all the way along that mile stretch. Would the water line be lower at one end, or would it be equal all the way along through our construct? Would the construct be parallel with the surface of the water?
Construct would be parallel with the water, but the ground would be different.
Aye, but it's the water that we're going by and the plumb line.
The water on the, aye, should be, aye.
So what I'm trying to push for is to get this done, right? But even if we done it our half a mile, the reason why is because there's people out there that claim the world's a round ball, right? Now, the only way for me that I can come up with to test that would be to build a construct like that. A half a mile long trench, let the water settle, and be built from our datum line, which is the plumb line. And if the water's really curving downwards, then when we build that, the gap's going to increase as we go further along. Would you agree with that?
Aye.
That's what should happen if it's curving downwards.
If it was long enough, aye.
You ever thought about it?
Not really, no.
If I says to you, how can plumb and level apply to a round ball? How can you fathom that in your mind?
Good question.
Do you believe it's a round ball?
Aye.
Honest, just an honest answer. What makes you believe that? First thing comes to you.
You fly in a plane, you can fly point to point.
Planes fly parallel with the ground though, they don't curve.
Aye, but if I kept going in that direction,
You think-
plane,
you think you
would
come back?
eventually come back to this direction.
But nobody's ever done that. They've just said all that stuff. That's the point. They say all these things, but the actual measurement, the science isn't there. But if I build this construct, it's going to show it, is it no?
Aye.
Appreciate it for your time, buddy. Think about it, man. Think about it. Cheers. Mate, my name's Dale. How's it going?
Aye, not bad, mate. Not bad.
The puzzle is, we've got a piece of ground, right? And from the starting point to the end point, it's over half a mile long, right? But it drops down 4 inches from one end to the other, right? If I build my plumb line at the highest end of that, and from my plumb line, that's my starting point, and I build perfectly squared blocks from my plumb line all the way across the length of my piece of ground, will the gap increase at the bottom, showing me the deviation of the earth underneath from my construct?
Aye.
It would, wouldn't it? If I jump one further, if I dug a trench half a mile long, and I filled it with water and it was watertight, and I let the water settle, I would have a nice level surface, wouldn't I? Half a mile long trench,
Aye.
filled it with water, the surface of the water will show me that it's a nice level
Aye.
length.
Aye.
So same again, at one end of this trench of water I put my plumb line, and I build the same square blocks again for that half a mile across the top of the water. Will the gap increase or decrease between the bottom of the bricks and the water surface, or will it just be even all the way?
Even.
Be even all the way, won't it? Because water always finds its level. Plums, square, can't go wrong with it.
Aye.
Do you believe the earth's a round ball?
Dunno.
Do you think plumbing level can apply to a round curved surface?
No.
Can you get on a curve and still be plumbing level?
No.
But we use plumbing level all the time. So what my aim is to try and push for this, to get this built. So we dig a trench half a mile long and we construct a plumb line with bricks that are squared to the plumb, and if the earth was curving downwards from any point, then the water line's going to show it. Would you agree with that?
Aye.
It's worthwhile, is it no? Do you believe it's a round ball?
Dunno. Never thought about it.
Never thought about it. Is what I've said to you made you think about it?
Aye.
Because what I'm saying to people is, like, what does the real world show us what we can demonstrate as compared to what we see on the TV? Because if you think about it, you've never experienced the earth as a round ball, have you?
No.
The horizon's level, water's always level, plumb lines are always perpendicular to the level. Can't be curving.
Dunno. No.
So, appreciate you for your time. Thanks for the answers, my man.
Nice, mate.
Take it easy, alright? Right, the puzzle's this, right? We've got a piece of ground, right? And from one end to the other, it drops an elevation of 4 inches, right? Now if I start at the highest end and I put a plumb line there, and I build a post that's nice and plumb on that, and then from my plumb line, my post, I build square blocks that are square to each other, and I build them all the way out, perfectly parallel with each other, all the way out, will that show me that the earth underneath's dropping away as we build it out?
If you're building at level?
Aye.
Aye.
Go another step, right? If I dig a trench half a mile long,
Right.
and I fill it with water, and I let the water settle, I'll get a nice level surface. You agree with that?
Aye.
Then do the same again. At one end I put a post, plumb, and I build my square blocks parallel to each other all the way along that water line. Will the gap increase between the top of the water and the bricks, or will it stay the same all the way?
Should stay the same all the way.
Because water finds its
Water-
level.
water finds the same
Plumb's perpendicular to the level all the time. What I want to do is get this done. The reason is, there's people out there that believe that the world's a round ball. No, listen. How can plumbing level apply to a round ball?
Round ball.
How can it? Have you ever thought about it? Can you get plumbing level on a bar?
No.
No, in the real world you can't.
You can't.
So if the world really was curving downwards,
Coming downwards.
if I build that construct across the water should start to dip down as I get to the end of it. You agree with that?
Aye.
If it was really
If
curving.
it's curving, aye.
If it was curving, but it's no curving.
No curving.
I'm going to try and get it done. Cheers for that.
If you use your laser,
Right, so say that again right now. Right, you said what?
if you dig a track, a 6 metre length track,
Yeah.
right, to lay your drainage, and you set your laser up,
Yeah.
right, you follow that laser, wherever that laser goes, that's where your manholes to go at the other end.
Aye,
And I've seen guys doing it
yeah.
and end up 2 metres after fucking
Using the
using the laser.
laser. But water would be more accurate than the laser.
Accurate.
Of course it would.